My name is Arturo Sanchez and I'm part of Group 1.
Go.
I'm Mia Trevino and I'm part of Group 1.
I'm Juan Garcia. I'm part of Group 1.
So we've pinpointed the 3 trees that we're using for our project on campus. Tree A, Tree B, and Tree C right here. And you can see my 2 group members here. We are between the Magic building, the math building, and the education complex here. So this is the location on campus of which we are conducting our project. So after measuring the shadows of the trees and as well as my height, we got, my shadow was 33 inches and my height is 63 inches. Tree A's shadow was 202.5 inches. Tree B's shadow was 193.4 inches. And Tree C's shadow was 299.7 inches.
Hello, this is Juan Garcia for Group A's calculations. For the measuring of the sides of our triangle, we just measured outside with the measuring tape, getting 268 inches from A to B, 489 inches from B to C, and 472 inches from A to C. From there, we had to find the angle, so we used the law of cosines, which the formula was c squared equals a squared plus b squared minus 2ab cosine c. From there, I plugged in the numbers 268 squared, 472 squared, plus 489 squared, minus 2ab cosine c, which gave me 71,284 equals the rest of the numbers right there. From there, I put brackets around that area to concentrate that I was doing the beginning part of moving over the 461,905 and 461,616, adding those 2 together and subtracting from the left side, giving us here at the bottom cosine C equals 390,621 negative 390,621 divided by 461616, which then after that process we do the arc cosine, giving us arc cosine 0.84, which gave us the answer of 32 degrees as our first angle, which would be plugged in here at the bottom at this angle. Given that we just found the angle angle C of our triangle, we go to the second part of finding the second angle, which we use law of cosine since we have one angle and we have we have known sides, which I put sine C over C equals sine A over A. That's the formula. We plugged in sine 32, which was the degree here at the bottom, and 268, which was the C side. Going from there, we put sine A, because that's the unknown, and 472 underneath. After that process, we move over the 472 to the top of the left side of the equal sign, which is 472 sine 32 over 268. After that, honestly, I just calculated the rest of that problem because the sign over here, it equals sine C. Sine C equals 472 times 0.529991, all those numbers, divided by 268. Then you have to move the sign over, which is arc sine, which plugged into the calculator equals 69 as our second angle. After finding the 2 angles on a triangle, usually the 3 angles not usually, all the time they should equal 180 degrees. So I just added up the 2 angles that we found, which was 32 and 69, giving us this formula: 32 plus 69 plus x, which is our unknown, equals 180. 32 plus 69 equals 101. 180 minus 101 equals 79. Equals 79 degrees, and that is our angle A. Now that we have the sides and the angles, which our angles are found with the formulas, our sides are found with measuring outside the trees. We did the height of the trees now. The height of the trees was found by using the shadow way, using Mia's shadow because she was the one that did the calculations at the time of the trees with the sun. For tree A, we got the shadow height of the tree was 202.5 times her height divided by the height of her shadow, or the length of her shadow, which equals 386 inches, which I will converted it to feet, which was 32 feet. For the tree equals 32 feet. For tree B, it was 193.4 using the same method, giving us 30.75 feet. And for tree C, it was 299.7 times 63, which gives us 47.67 feet. Okay, now that we found the sides, the angles for our triangle, and the height of our trees, it's time for the perimeter. Our perimeter, we add just 3 sides, 268, 472, 49, which equals 1,229 inches. And for the area of our triangle, we use Heron's formula, which over here, we use the semi-perimeter, which is A plus B plus C divided by 2. Now we use Heron's formula, which is, don't mind the S on the side, but the S inside the square root, so it's S times S minus A times S minus B times S minus C, the square root of that, which gave us 61,708.06 inches squared.